Now let us derive the equation of motion, which is uniform accelerated motion, the three equation of motion, and we will derive this equation with the help of integration and differentiation. Integration and differentiation. We will derive the equation with the help of integration and differentiation. We know the first equation of this first equation equal to V equal to U plus A T. Next, the second equation of this will be equal to S equal to U T plus half of A T square, and third equation will be equal to V square equal to E square plus 2A and S. Whereas we know the V is the final velocity of a particle which is moving, and U is the initial velocity of the same particle, and A is the acceleration of the particle which is uniform acceleration, and T is the time taking to move the S displacement, S time displacement, and U is the initial velocity, V is the final velocity, T is time required, and A is the acceleration. Now we will derive this equation with the help of integration and differentiation. We know the V will be represented by the term of differentiation. This will be equal to ds by dt. Arthat mean the V velocity will be equal to displacement divided by time taken, ds by dt. Similarly, we derive the acceleration. This will be equal to d2s by double differentiation of s by d2. Okay, so with the help of this differentiation and integration, we will derive this formula. We know the acceleration of the particle. Acceleration of the particle will be represented by the acceleration of the particle will be represented by the acceleration will be represented by the dv by dt. dv by dt. This will be equal to dv by dt. This will be equal to dv by dt. So from this a dv by dt, we get from this a dt is equal to dv. A dt is equal to dv. Suppose a particle moving from position A to B, whereas u is the initial velocity and v is the final velocity, s is the displacement from A to B, and t is the time required, and a is the acceleration. We know that a is the acceleration. Okay, this is the acceleration. So from this we will try to derive the formula of v equal to u plus at. U plus at. Now we will integrate this formula. A dt equal to integration dv. Okay, a dt equal to integration dv, whereas this will be, write down this dv equal to a dt. Now the limit of this v, we know limit here is u to v. The limit here is u to v, and the time limit is 0 to t. Time is starting from 0 and finishing at t. So from this, after integration, we get this will be equal to v this will be equal to v u to v equal to, whereas a is the constant term, because we know that uniform acceleration, so a is the constant term. So from this we get a dt, integration is t, which will be vary from 0 to t. So from this we get v minus u equal to a t minus 0. Okay, t minus 0. So from this we get v minus u equal to at, because 0, when 0 will be multiplied by a, this will be equal to 0. So we get v minus u equal to at. So from this we get v equal to u plus at. This is the first equation of motion, v equal to u plus at. This is the first equation of motion. Next we will derive the second equation of motion. The second equation of motion, we know this will be equal to s equal to ut plus half of at square. Second equation of motion, we know the s equal to ut plus half of at square. So we will try to derive this with the help of integration and differentiation. Next we will derive the equation v square u square plus twice s, which is the third equation of motion. Okay, now we will derive the second equation of motion, which is the uniform acceleration, where we have already considered this is the uniform acceleration, and this particle are moving from 0 to a distance moving from 0 to a. From this we will get the equation s equal to ut plus half of at square, Next we know that s equal to ut plus half of at square. We know this will be equal to, again we know v equal to, for this equation, for second equation, for the derivation of the second equation, we know v equal to ds by dt. ds is the small change of s and t is the small change of time. So from this we get v dt equal to ds. Okay, v dt equal to ds. So from this we get ds equal to v dt. So from this ds equal to v is the u plus at. We will put the value of v from here, from the first equation. This will be equal to u plus at dt. Then we will integrate this. So the integration limit will be the same integration limit when a particle moving from point A to point B. Here the velocity is u, and here the finishing velocity is v, and the displacement is s, and a is the acceleration, and time starting from 0 and time finishing to t. So from this we will put here the integration limit, whereas s is starting from 0 to s. And the t is starting from 0 to t. From this we get, this will be equal to, there are two integration, 0 to t u dt plus a t and dt. Integration limit is 0 to t. From this we get this. So u is the initial velocity. So u is the initial velocity which is the constant. So u will remain constant. This will be equal to, from this we get u equal to u, this u will remain constant, u will remain constant because this is the initial velocity, u will remain constant. From this we get from this we get, this will be equal to, from this we get u after integration we get u t varying from 0 to t equal to 0 to t u varying from 0 to t, u varying from 0 to t. From here we get ds equal to, so from here we get ds equal to, from here we get s varying from 0 to s equal to u is the constant, t varying from 0 to t plus 0 to t plus a t dt. Whereas the integration of t, this will be here, a is the constant term and integration of t will be equal to t square by 2. We know if t n plus 1 by n plus 1, n plus 1 divided by n plus 1, n means the power of t is n plus 1 divided by n plus 1. Here the power is 1, so this will be 1 plus 1 means 2 and divided by 2. So this will be equal to a t square by 2. From this we get s 0 to s means s will be s only, this will be the s, ut 0 to t means this will be equal to ut plus half of a t square. This is the second equation. This is the second equation, which is the second equation of our linear uniformly accelerated motion second equation. Accelerated motion second equation. This is the uniform accelerated motion second equation. Now we will derive, this is the second equation derivation with the help of integration. Now we will derive the third equation. Which will be equal to v square u square plus twice as, v square u square plus twice as. Now we will derive the third equation, v square u square plus twice as. Now let us derive the third equation, which is v square u square plus twice as, v square u square plus twice as. Third equation of motion, which is the v square u square plus twice as, v square u square plus twice as. Third equation of motion, which is v square u square plus twice as. Now the derivation, now the third equation is v square u square plus twice as. Again we know the acceleration a will be dv by dt, velocity, derivation of velocity with respect to time. Now this will be write down in this way, ds by ds. Whereas ds by ds, it has no meaning. It is the meaningless. So from this we derive this ds by dt, ds by dt into ds by dt into dv by ds, ds by dt into dv by ds. Okay, dv by ds. So ds by dt, we know this ds by dt, this will be equal to ds by dt means this will be equal to v and this will be equal to dv by ds. After that this will be equal to A ds equal to V dV. A ds equal to V dV. A ds equal to V dV. So A ds equal to V dV. Now we will integrate this. The both side we will integrate. We will integrate this. Now the change of displacement from 0 to S, A to B, 0 to S. Similarly, U to V, velocity changing from U to V, and displacement 0 to S, time changing from 0 to time changing to T is equal to T. So put here the integration limit. This S equal to 0 to S, and V changing from U to V. This will be equal to U to V. G changing from U to V. Now after integration, here A is the uniform acceleration. So A will be equal to constant. This will be equal to ds. This will be equal to S. This will be equal to S. This will be equal to S changing from 0 to S equal to, from this equal to, this will be the integration of this. Similarly, the power here is 1 and this will be add with 1. So this will be equal to V square by 2, V square by 2, V square by 2, which will changing to U to V. V square by 2 changing to U to V. So from this we get AS equal to V square by 2 minus U square by 2. V square by 2 and U square by 2. So from this we get V square. So from this we get V square equal to U square. V square equal to U square plus 2AS. The third equation. After LCM of 2 we get 2. After LCM of 2 we get 2. So this 2 will remain same. So V square minus U square, 2 will be multiplied here 2AS. This is the 2AS plus U square. If we take this in the left side, this will be equal to 2AS plus U square equal to V square. After changing all side, we get V square equal to U square plus twice AS. This is the derivation of equation of motion using integration for uniform acceleration. Okay.